discuss about case study and assertion questions for the board exam, term 1 for the chapter 1, electrostatics, electric charges and field. So, first case study is Gauss law for the electric field describes the electric field generated by a distribution of electric charges. It states that the electric flux through any closed surface is proportional to the total electric charge enclosed by this surface. By conversion, a positive electric charge generates a positive electric field. The law was published posthumously in 1867 as part of a collection of work done by the famous German mathematician Carl Friedrich Gauss. Okay, so this is the expression for the Gauss statement. Okay, surface integral of EDS will be equal to total charge enclosed by epsilon naught. So to electric field lines entering any closed surface, let this be a closed surface and electric field lines are entering the closed surface. Okay, and it is piercing through the surface and leaving here. Okay, so this electric field lines per unit area we call it as flux. Okay, so according to Gauss law, the total flux of any closed surface will be equal to 0. Okay, Gauss law cannot be used to find out the following quantity. Gauss law can be used to find out, so what is the formula we have? Pi is equal to total charge enclosed within the surface divided by epsilon naught. So from this we can calculate the electric field. Okay, this is the statement of Gauss, mathematical expression for Gauss law. So from this we can calculate the electric field, we can calculate the charge and we can calculate the permittivity. We cannot calculate the electric flux density. So option is B. Okay, density cannot be calculated. Select the correct statement from the following. The electric field due to a charge outside the Gaussian surface contributes 0 net flux through the surface. So for the first one, electric field due to a charge, consider this is a closed surface. Example, consider this is a closed surface and we're placing a charge here. Okay, and we're placing a charge, example minus q is a charge placed outside the surface. This is the Gaussian surface. Gaussian surface is an imaginary surface that encloses the charges present in an object. Okay, so here minus q outside. Now the electric field due to a charge outside the Gaussian surface contribute to 0 net flux to the surface. Yes, we have flux is equal to 0 in this case. For the second statement, total flux linked with the closed body not enclosing any charge will be 0. Consider this is a closed surface, there is no charge inside. Okay, so the electric field lines entering and leaving will be equal. So entering field lines will be equal to leaving field lines, no charge is there, so we'll get flux as 0. Okay, entering electric lines will be equal to leaving, and pi there is no charge, so pi is equal to, we know pi is equal to q in by epsilon naught, so no charge means 0 by epsilon naught, so we'll get pi is equal to 0. Okay, the third one is total electric flux if a dipole is enclosed. So dipole is nothing but two charges with equal magnitude but opposite sign separated by a distance, small short distance. Okay, 2r. Now total, so what happens to this total charge due to dipole plus q and minus q, will get the net charge value to be 0. Plus q minus q gets cancelled. So when there is no charge inside the closed surface, total electric lines entering and leaving will be equal to 0. So we'll get pi is equal to no charge, right? So q by epsilon naught, so 0 by epsilon naught will get answer as 0. So all the three statements are correct. Okay, so option D is given as 1, 2 and 3. Okay, all the three statements are correct. This is the answer. Option D is the answer. All the statements are correct. So next one, the figure shows a part of an infinite plane sheet, okay, of charge. Which of the following graphs correctly shows the behavior of electric field intensity as we move from point O? Okay, point O is here and point A is here. It is given the diagram. So as we move from point O to A, what is the behavior of this electric field with respect to the distance? So for infinite plane sheet, we get the formula for electric field intensity. After derivation, we get the final expression as E is equal to sigma divided by 2 epsilon naught. So from this, we say that E is independent of distance R. Okay, let the distance be R. From O to A, it is independent of distance. The electric field is independent of distance. Okay. So we take the first graph. So you have to choose which graph suits the condition when electric field is independent of distance. Here if you see, the electric field is varying with distance, okay, increasing. Here the electric field and distance, we can see it is varying, it is decreasing, electric field is decreasing. Here we say electric field remains constant. Even if we increase the distance, electric field remains a constant. Here it decreases and then increases. So which is independent among the four graph? The option graph C, because the electric field is independent. Even if you change the distance from 0, 1, 2, 3, whatever may be the R distance, the electric field value remains the constant. So C is the correct answer. Okay, in Gauss theorem, number of electric field lines entering the surface, as I told you, right, electric field line entering the surface will be equal to the field lines leaving the surface. So if this is a closed surface and the electric field lines entering the surface will be equal to the electric field lines leaving the surface. So entering will be equal to leaving for any Gaussian surface. So answer is equal. Okay, next is a plane surface is rotated in a uniform electric field. When is the flux of the electric field through the surface is maximum. Okay, so electric field is entering and we have the normal vector. Okay, normal vector, normal area vector. Okay, we have the area vectors perpendicular to the surface. Okay, so area vector perpendicular to the surface. These are the surface of the any plane surface. Example, I am taking this diagram. Okay, so it's a plane surface where the electric field will be perpendicular to the surface in case of here electric field is perpendicular, here the electric field is perpendicular. So electric field is entering and leaving like this. Okay, in this case the electric field will be parallel to the surface, and in this case also electric field will be parallel to the surface. So for surface 1, let it be surface 1, this is surface 2, this surface 3, and this surface is 4. Okay, so for surface 1 the electric field is perpendicular, okay, and for surface 3 is electric field is perpendicular to the surface. For surface 2 and surface 4 the electric field is parallel to the surface. Okay, this is the surface. Okay, there are 4 surfaces for this diagram. Okay, so when we get maximum, we know the formula phi is equal to EA cos theta. Okay, so when we get it to be maximum for the entire surface, so when theta is, substitute for theta equal to 0 degree, we'll get cos 0 as 1. For theta equal to 180 degree, cos 0 is minus 1. For theta equal to 90 degree, we'll get cos 0 as, okay, this is for cos theta values. Cos will be 0. Okay, substitute for cos theta. And when you find out this electric field, okay, and the electric field and E denotes a normal vector. The electric field E and electric field A. Okay, here it is 90 degree. The angle here it is 90 degree between here. So for surface 2 and for surface 4, we get the pi value as 0. For surface 2 and for surface 4, we get EA of cos 90 degree. Okay, so we'll get the answer of 0 for 2 and 4. And for surface 1, okay, for surface 1, E and A, they have the angle between both are in opposite direction. So theta will be equal to 180 degree. Okay, for first surface, E and A are in opposite direction. Theta is equal to 180 degree. Therefore, phi 1 will be equal to minus will get minus EA. Okay, so my negative value will be getting. Okay, some negative value will be getting. And for the surface 3, okay, and for surface 3, what will be the value for surface 3? Surface 3, E and A are same direction. So theta will be parallel. Okay, E and A are parallel in same direction. So theta will be equal to 0 degree. Therefore, cos 0 will get it as EA. Okay, cos 0 will get value to be some EA, positive value will be getting. Okay, EA value will be positive value. So we have to find out for which the flux surface has maximum, electric field to the surface is maximum. So for at surface 3 we have maximum. In this surface the E is perpendicular to the surface. E is perpendicular to the surface. Okay, so the option is A. A is the answer. So you'll get maximum when the electric field is perpendicular to the surface. Okay, next. What is the electric flux through a cube, okay, which encloses an electric dipole? So as we said, electric dipole, equal and opposite charges, so it gets cancelled. So total flux will be equal to Q in by epsilon naught. So equal and opposite charges gets cancelled. So the net charge will be equal to 0 by epsilon naught. So we'll get answer as 0. So answer is D, option D. Okay. Next, for the next question, a point charge Q is placed a distance of a by 2 directly above the center of the square of side A. The electric flux through the square is, okay, through the electric flux through the square is what? Consider any one of the square, any one of the face of the cube. Consider any one face of the cube. Okay, cube has square faces. Okay, you have 6 faces. Consider any one face and a charge is placed at the center at a distance of a by 2. Okay, so what is the total flux for the entire cube? For the whole cube it will be Q enclosed by epsilon naught. Okay, so Q enclosed by epsilon naught is the flux for the whole cube. Okay, now we have to find out what is the flux for any one face. For any one face. Okay, so what could be the flux for any one face? So how many faces are there? How many faces are there? 6 faces. Okay, for 6 faces, the answer is Q by epsilon naught. Now we have to, for entire whole cube means we have 6 faces. Okay, for 6 faces, that is for whole cube. It is Q by epsilon naught. Therefore, for any one face, what could be the value? Okay, because we are asking the charge is placed at the center of a square. We are considering any one surface. Okay, any one surface we can consider. Therefore, for one face, the pi will be equal to Q by 6 epsilon naught. Okay, for 6 faces it is Q by epsilon naught. Then for one face it will be Q by 6 epsilon naught. So the answer is option B. Okay, next. Which of the following statement is not true about Gauss law? Gauss law is true for any closed surface? Yes, we dealt right. Gauss law is applicable only for closed surface. Term Q on the right side of Gauss law indicates the sum of all charges enclosed by the surface. Yes, correct. So Gauss law Q by epsilon n. So right side Q gives you the total charges enclosed. Then Gauss law is not much useful in calculating the electrostatic field when the system has some symmetry. You can apply Gauss law only when the system is symmetry. Okay, only when system is symmetry, Gauss law can be applied. Okay, here they are given Gauss law is not much useful in calculating electrostatic field when system is some symmetry they have given. Okay, so option C we can is not a true one. Let's check it out for D. Gauss law is based on the inverse square dependence on distance contained in the Coulomb's law. Yes, it is based on the inverse square law. That is 1 by r square. Okay, so the option which is not true is C. Only with system is symmetry we can apply the Gauss law. Next, two unlike charges separated by a distance of 1 meter attract each other with a force of 0.108 Newton. If the charges are in the ratio of 1:3, then the weak charges. Okay, charges, let consider two charges are there. Let two charges are there in the ratio of 1:3. Okay, so let the one charge be Q and the other charge be, let one charge as Q and the other charge to be 3Q, because it is a ratio of 1:3. Okay, so at A it is Q, you can consider, at B it is 3Q. So in the diagram at A it is Q and at B it is 3Q. Okay, they are separated by a distance of 1 meter. Okay, now we can apply the Coulomb's formula here. So what is the Coulomb's formula? F is equal to K into Q1 Q2 divided by R square. So K 9 into 10 to the power of 9 and Q1 is Q into Q2 is 3Q. 2 charges Q1 3Q divided by 1 meter. 1 square is 1. Okay, so 9 into 10 to the power of 9 into 3Q square divided by 1. What is F value they are given in question? F is equal to 0.108 Newton given in the question. Okay, so substitute the F value here, 0.108 Newton. So therefore Q square will be equal to 0.108 divided by 9 into 10 to the power of 9. Okay, so we'll get the answer as Q, therefore Q square is equal to 0.004 into 10 to the power of minus 9 Coulomb. Just take the square root of this, 0.004 into 10 to the power of minus 9. We'll get the answer as Q is equal to 0.02. Okay, take the square root, will get 0.02 into 10 to the power of minus 3 Coulomb. Okay, so Q is equal to 0.02 into 10 to the power of minus 3 Coulomb, but the option, you can check it out, the option is there, it is in the terms of 2 microfarad. So just multiply and divide by 3. So Q is equal to 0.02 into 10 to the power of 9, multiply and divide by 3. Okay, so we'll get 2 into 10 to the power of minus 6 coulombs, which is equal to 2 microcoulomb. Just adjust the powers in the favor of the choices. 2 microcoulombs, you have to get 2 microcoulombs, just multiply and divide by 10 to the power of 3. Okay, so answer is A. Okay, next question is, if the electric field is given by 6I plus 3J plus 4K Newton Coulomb, the flux through a surface of area 20 meters square in the YZ plane. Okay, so consider a surface placed in the YZ plane. Okay, some consider surface that is placed in the electric field. Okay, so YZ plane. Consider surface and the electric field is entering and leaving, and the surface of area 20 meters square. Okay, so surface vector, which will be a normal vector, okay, will is along the x-axis. Okay, area vector is along the x-axis, which is given as 20 meter square. Okay, so what could be the electric field? So electric field will be equal to, okay, then flux. Okay, electric field is given as 6I plus 3J plus 4K they are given. Then you have to area vector, they are given as, area is given as 20 meters square. Okay, therefore area vector is parallel to x-axis, and the area vector when it is perpendicular to the surface and parallel to the x-axis. Okay, area vector is perpendicular to the surface and parallel to x-axis, is area in terms of area vector will be 20I. Okay, therefore flux is equal to E into A. So 6I plus 3J plus 4K multiplied with 20I. So I'll get 120 units. So pi is equal to 120 units. Option is B. Next, if the electric flux entering and leaving an enclosed surface respectively is pi 1 and pi 2, then the electric charge inside the charge will be. So from the Gauss law we know that, what is Gauss law? Pi electric field. Okay, what is Gauss law? Pi is equal to Qn divided by epsilon naught, total net charge. Okay, they are saying the entering flux is pi 1 and the leaving flux is pi 2. Okay, entering and leaving flux is pi 1 and pi 2. Okay, so pi 2 is leaving and pi 1 is entering. Now we have to find out what is the charge, total charge enclosed. We have to find Q1. So net flux will be pi 2 minus pi 1 will be the total flux. Okay, so total flux will be pi 2 minus pi 1. So pi 2 minus pi 1 is equal to Qn by epsilon naught. Therefore pi 2 minus pi 1 into epsilon naught will be equal to your total charge. So the option is, this is option A is pi 2 plus pi 1, this one pi 2. So sorry, this could be pi 2 minus pi 2 is also wrong. Pi 1 plus pi 2 is also wrong. You have to get pi 2 minus pi 1 into epsilon. So option is D. Okay, just substitute in the Gauss mathematical expression, Gauss statement expression, just substitute, then you will get the answer. Okay, next is a cylinder of radius r and length L is placed in an uniform electric field E parallel to the axis of the field. So this is a cylinder and electric fields are parallel to the axis of the cylinder. The total flux over the curved surface area. So this is a curved surface area and this is also curved surface area. Okay, so for the curved surface area, the electric field lines, okay, electric field lines parallel to the curved surface area electric field line is parallel to the curved surface area, and the normal area vector is perpendicular to the surface. Okay, so what is the angle formed? EA cos theta. What is the angle formed here between the area vector and the electric vector? Is theta is 90 degree. Theta is equal to 90 degree. Therefore, pi will be equal to 0 because cos 90 is 0. So the option is A. Next is consider the lines of force. Okay, consider the lines of force as shown in the figure. The electric field lines. 2 unit positive charges are kept at point A and B. Which of the following is correct? Charge at A will suffer greater force. No, the electric field lines, since it's a positive charge, the electric field lines are coming away from these charges A and B. So A and B will be a positive charge. Okay. Okay, charge A will suffer greater force. No. Here the electric fields are starting point here means it has a high potential here. So electric field lines moves from high potential to low potential. High to low. Okay. So the amount of charge potential here will be high and potential here will be low. Okay. Charge at A will suffer greater force. No, the electric field and the force for positive charge will be same direction. And have a maximum force at this point. As the distance increases, the value of electric field also decreases. Okay, r square. So electric field varies with respect to distance. So charge at B will suffer greater force. Force at both points will be same, but non-zero same. Okay, force at both points will be same? No. Force at both points will be in the same, D. That is also wrong. Okay. So charge at A will suffer greater force. Charge at B will suffer greater force. Which will be suffer greater force? We have to find out. So here A is far away from this electric field lines. That is far away from this high potential. So A is far away from the high potential. The charge A is far away from the high potential. So it suffers less force. Okay. By any test charge is placed, it suffers less force. Okay. When the charge P is close to this high potential, okay, so when you place a test charge, here, okay, this test charge will repel. Okay, there will be a repulsive force between this test charge and the positive charge PQ. So it suffers greater force, which is close to the high potential region. So the option is B, which suffers B suffers a greater force. Okay, both are non-zero at points will be same. Both force at both points will be the same. So the option is B because B is closer to high potential region. This high potential region and this will be low potential region. Electric field lines will move from high potential to low potential. That point we have to remember. Okay. Next we'll see about the assertion type questions. So we know that assertion, right? We'll choose option A when the assertion and reason both are correct and the reason is also correct. And option B will choose when assertion, reason, correct statement, but reason is not the correct explanation for the given statement. And we choose C when the reason is wrong, and we choose D when the assertion statement is wrong. Okay. First is assertion is no two electric lines of force can intersect each other. This statement is a correct statement, right? If this is one electric field line and this is another electric field line, both cannot intersect at a point. Okay, both cannot intersect. If it is intersect at a point, then the resultant electric field will have two electric field lines. Okay, you have a two electric field lines. It is not possible at a point in the electric field line, that is at a point in any point in the electric field line, the tangent drawn to the electric field line will give you the value of the electric field at that point. Okay, tangent drawn at that point. So at any point you can have only one electric field strength. You cannot have two electric field. Two tangents cannot give you the electric field at a point. That is, at a point you should have only, at a point has only one electric field strength. You cannot have two. If there are two lines, line 1 and line 2 lines are there, and when they intersect it gives rise to two tangents. So a point cannot have two electric field lines in two different directions. A point can have only one electric field line in one direction. So assertion is correct. Tangent at any point of electric field line of force gives the direction of electric field. Okay, so both the reason is also correct. As I told you, that tangent gives the direction of the electric field at any one point. So assertion, reason, both are correct. So A statement, R statement, reason statement, both are true, and reason is also the correct explanation for the assertion. Next is Coulomb's law of force is applicable for point charge at rest. Okay, it's a correct statement. We know that Coulomb's law is applicable for point charges at rest. Coulomb law is a central force. Okay, so this is not a correct explanation. So for Coulomb's law of force is applicable for point charges at rest separated by a small distance, and the A and R are correct statements. Both are correct statement, but R is not the correct explanation for A. A is assertion statement, so option is B. Okay. Electric charge is quantized. Yes, correct. Assertion is correct. True. Reason. Charging is because of transfer of an integral number of protons or electrons. Okay. Charging. Reason. Charging is done. They are given both proton transfer or electron transfer. Okay. Reason is charging is done by the transfer of electrons only. Okay, so they are given by both the protons and electrons, so this is a false statement. So A is true, but the reason R, okay, it's not correct explanation of A. Okay, it's not a correct explanation and it is a wrong statement, so option is C. What is the correct statement? Charging is done only by electrons. Only electrons can move. Here they are given proton, which is a wrong one. Okay, so the reason is wrong statement. Okay, if there exists a Coulomb attraction between two bodies, both of them may not be charged. Okay, if there is a Coulomb attraction between two bodies, both of them may not be charged. So you can have two bodies. One body can be charged, other body may not be charged. There will be a attraction. Okay, you can have a, it may be charged. Both the bodies may be charged or may not be charged. If there exists Coulomb attraction between two bodies, both of them may not be charged or may be charged. May be or may not be. Okay, so assertion is correct. Assertion statement is true. In Coulomb attraction, two bodies are oppositely charged. No, this we told that may be charged or may not be charged. So they can be same charge or opposite. Sorry, attraction. Two bodies are oppositely charged, or one body can be oppositely charged or other body may not be charged. Okay, so here the reason is not the correct explanation. Okay. So reason is not the correct explanation for the statement. Okay, so assertion is correct. Okay, an attraction, two bodies of both of them may not be charged. That is correct. In Coulomb attraction, two bodies are oppositively charged. They are given. Okay, two bodies are opposite each other. So one body can be what? May be charged. They may be charged. Or may not. They are giving. It is compulsory. Two bodies are oppositely charged. Okay, it is not like that. One body can be charged. Other body cannot be charged. One can be positive. Other body can be negative. One body can be positive. Other body may not be charged. Okay, so the reason is not the correct explanation of the statement. Hope you have understood. Kindly subscribe, like and share with your friends. Thank you so much.